Hi everyone, I'm Glenn, which is established on the product team here at Infracost. If you've not heard of Infracost before, I'm really excited to be the one to introduce it to you. We're a platform that helps engineers catch expensive mistakes before they happen. Or if you're in part of a FinOps team, we can help you become proactive instead of reactive to managing costs and cloud waste. Today, though, if you have heard of Infracost, you're probably familiar with our Terraform experience and the fact that we've been doing cost estimation around that for many years at this point. Today, though, we're going to be talking about CloudFormation and CDK instead. So just to check, you can see my slides now, Michelle?
Cool. Yes.
Excellent. So just quickly, what we're going to go through today is I'm going to show you how to catch unexpected costs before they happen, why it is so difficult to do that, and why people can't do that necessarily get it right the first time. It's a really, really tough challenge. And how you then go about making good continuous improvements to that, because even if you have the best guardrails in place and the best type of policy to stop this stuff, there are plenty of reasons why you'll need to actually go back and modernize or remediate things that are out there already. But let's start with a few examples, and these are drawn from actual customer experience. These are the type of things we see every single day with the customers we work with. Here's the first example. This here is a CloudFormation template. It's a dozen or so lines of YAML. The interesting thing here for this particular example is that line in the middle that says instance type M8A 2x large. So let's say this is a web server, for example. Your engineering team has been looking at the utilization on it, seen that it's overutilized, that you need to move to a larger instance. And so someone comes in to make that change for you. Well, this instance, for example, is about $350 per month to run, but you want to go up to one that's twice as large. And so what you want to do is make this particular change here. Go from a 2x large to a 4x large. That'll jump you up to about $720 a month. Now, it's not easy to know what all these prices are off the top of your head. We wouldn't expect most people to do that. This is a pretty reasonable change. It's also very, very easy, though, to fat finger this, and we see this quite often, where you don't replace the 2, you just put the 4 in. And this change is all of a sudden $4,200 a month. A very, very big jump from the $750 that we would have been expecting. One character difference. Now, if this is the only thing that's going into a pull request, that one character change, you might catch something like this. That's not typically what happens. This is usually part of a larger change set with autoscaling groups, databases, other things changing at the same time. And so it's exceedingly difficult to catch that one character that got wrong here. Another thing we see, pretty common. Someone is using maybe a service they're not particularly familiar with, but they know that someone else in the business is using it. And so they don't want to make a mistake. They want to follow best practice. And so they go looking for other repositories, other examples of how to use this technology. And they find the code and they copy it and they paste it. Not realizing maybe that their little project that they're spinning up and demonstrating to an internal team doesn't need a copy of the same underlying infrastructure that you're using in the production environment. You probably need something smaller. And so it's not obvious looking at this dozen or so lines of YAML that this is actually an $114,000 a year database. How could they possibly have known? Or just to take a particularly extreme example, again, this is about 19 lines of YAML here. Again, another database, but nothing particularly obvious here about how expensive this change would be. It's 500 gigabyte GP2 storage, but this is a SQL server with a license included and a pretty large instance, 24x large again. So depending on where you would run this, this is going to run you in the $60,000 to $68,000 a month, $800,000 a year for these 19 lines of YAML here. Again, it's really hard to look at these things. They all look fairly similar, but costs ranging from $320 for that first example, all the way through to $800,000 a year. And knowing what all these prices are is super difficult. So why is it hard? Well, let's take a step back and think about what your engineers are trying to do. They're trying to get stuff done, and I'm going to trust that all the engineers and all these companies are smart people with good intentions who are constantly and actively trying to do the right thing all the time. They're jumping in there to improve performance. They're going and looking for best practice and trying to copy that across the organization. But as we saw, all it takes is one single character to be wrong to be us 10x off what our intention was from a cost perspective. Now, the reason this is super hard is because what we're actually asking engineers to do when they're making these changes is try and, as part of their job, keep track of this incredible growth in pricing complexity. What this chart's showing is way back in 2012, when we looked at the data, there were 10,000 unique price points that we needed to track to be able to work out the cost of modern cloud infrastructure across the three major clouds. The numbers, when we ran them for 2021, jumped up from 10,000 to 3 million. And in the 5 years since then, it's gone from 3 to 10 million, more than tripled. We've added more than 300,000 new price points in the last month alone. That's because if a new region spins up with all of the services at one of the clouds, it's a whole nother price book. If a new region, if new service launches and it has to go across all the regions, same again. The pricing complexity around this is growing exponentially, and asking engineers to be able to keep track of all this stuff and how things are changing, whether prices are going up or down, new services, etc., and all the various usage and other ways that things are calculated, makes this so difficult. But keeping track of cloud costs and understanding what you're paying isn't exactly a new problem. We've been deploying cloud infrastructure for almost 2 decades at this point. The status quo, the common approaches for solving this right now are billing alerts. So you go into the cloud dashboard, you set up an alert, say if the cost increased by a certain percentage or a dollar amount, make sure you send us an alert. That works so long as those changes are actually an anomaly. If you're a really big organization with an already expensive bill, where do you set those thresholds without generating a lot of noise for people? It becomes difficult just because of the scale that you're operating at. Or you can do what a lot of people do and wait for the bill. Now, again, you're still having to hope that whatever changes happen month on month are actually anomalous enough for you to notice in the bill jump. The other challenge with these particular approaches is by the time you're aware of the problem, you've already provisioned the infrastructure. And most teams aren't deploying infrastructure, leaving it sit around for a month and then they start using it. They usually deploy it as part of their usage intentions. And so those changes are out there, you're incurring cost from the second they're deployed, and you're probably using it very quickly thereafter. And so going and changing those decisions after the fact is really disruptive to the team. They'll have to go work out how to provision new stuff, how to get the stuff, the workloads back onto that new infrastructure. It's just a very disruptive way of dealing with it. As I mentioned, you're already incurring costs. The second you've made that incorrect decision, you're already generating waste. There's no way to get that back. If you are using billing alerts or you're waiting for the bill to come through, how do you actually work out who you should go speak to go and find those problems? Hopefully you've got a good tagging policy in place. That's not always the case. And so just trying to trace the ownership and lineage of those changes in and of itself can be many hours work for some teams. And as that example I gave earlier with the 2x to 24x large instance jump, they can already be lost in the noise. If you're spending hundreds of thousands, even tens of millions of dollars on cloud already every month, a $4,000 or $20,000 change might just get lost in the noise of things. And if team A does that this week and team B does that next week, these changes compound. And so your bill gets bigger and bigger and bigger. And what starts to look like an anomaly gets bigger as well. Even though you've over provisioned something by 10x what you should have, it's just hard to tell that sometimes from the price alone. And as I mentioned, dealing with these things after the fact is literally the most expensive and disruptive way to catch these issues. You have to go and redo work. You have to go and change the workflow, and you're incurring costs. The longer you take to fix these things, the more expensive it is for you. So you'll hear us talk about shift left. And so if you're not familiar with the term, I thought a quick recap on what that means is worthwhile. Whether you're doing agile or scrum or waterfall or whatever your methodology is, there's still kind of a linear motion through time on how these things get out to production. You start with an idea, might go to the product or design team, architecture gets involved and helps define how that product should be built, engineering team goes and implements it, and then you go into production. And from the second it goes into production, you're now incurring costs. Money's being spent. You pay the bill, maybe that's the point when you detect these issues. You go back, make some changes, hopefully it's improved, but the longer you wait in that cycle after ship to production, the more waste you're generating. And so when we say shift left, what we're talking about is trying to move the intervention point further left in this flow before you ship to production, so that any changes you get, any changes you want to make, are before you're using that infrastructure and before you're incurring any cost for it. So it has the lowest impact to your business, but it also means you're not spending money on it. So what does that look like in practice? Well, here's an example pull request, and we'll go through a live demo of this later if the demo guides are treating me well. But I went and made that change that I was talking about before. We changed the 2x large to the 24 because I made the mistake, submitted the commit, pushed it up to the pull request that I was working on with that particular work, and then Infracost bot intercepted it and said, hey, this cost has increased by way more than you expected. In this example, it's 58,000 because that instance wasn't just a thing by itself, it was part of an auto-scaling group. And so it does a calculation. It says, if you make this change, given the number of instances you're going to run as part of this auto-scaling group, it's not just a $4,000 mistake, it's actually a $58,000 mistake in this particular example. And then, as I mentioned, we'll go into this later as well, but we have approaches that are helping you modernize. So sometimes these things either are already out live because you haven't been using Infracost, you didn't put the guardrails in place, or new instances get announced in reInvent and there's cost savings to be had if you upgrade. And so we're able to go and find those existing issues as well in your code base, and using Autofix, automatically generate PRs to help reduce the time it takes to go and remediate things that are already live. So this is an example of a Autofix pull request where we're suggesting you change the M3 X large to a M6G X large, a newer Graviton instance, you'll save $981 a year. Now, as I said, if you're familiar with Infracost already, that's because we've been doing this for many, many years with Terraform. We've built up a deep trough of experience around resource coverage with Terraform, but also the workflows around it, things like Autofix campaigns for dealing with remediation, the guardrails. I'm happy to say all of these things are now available as well for CloudFormation and CDK. So all of that amazing Terraform experience that we've invested many, many years in honing is now available across the board for these three IAC frameworks. And with that, I now plead to the demo gods and hope we can run you through an end-to-end example. So let me share my next screen. Okay, so this is the Infracost homepage. I'm going to log in. I'm going to take you through the flow from the very beginning. Log in with GitHub. Cool. If you're signing up for the first time, what you'll get is a quick onboarding flow. I've already filled that out just to save us a little bit of time through this demo. But and it will ask you to attach your GitHub and your VCS connections and what repos you want to connect. If you're already an established customer, have some signups and you want to add some new repos, just go here into the manage repo setting. You'll get a list of all the repositories we know about. I've already selected the CDK and Terraform ones, but it's as simple as that. You click that, say next, and we'll connect your repos and start syncing things. And so let's see what that looks like. So that's a clean slate now. We've connected our repos. I have 3 of them in here at the moment. What we'll do is we'll go and show you what it's like to make a change. So that's all I've done at this point is I've connected my repository and it's waiting for me to do something. So let's go into this YAML file and we'll edit it just directly in the GitHub interface. And what I'm looking for is, here we go. This is that snippet we saw earlier in the presentation. And we're going to deliberately make that mistake we were just talking about. So what I intended to do was change it from a 2x to a 4x large, but we're going to pretend that I fat fingered it and didn't notice and commit these changes. We're going to commit them into a new pull request. So this is going to create a pull request for us. I'm going to fill this in for now. All right, this creates the pull request. We can see Infracost is running. Just in the interest of time, what I'm going to do to show you how both of these work is do a similar change in our CDK example. So we'll open up our CDK file, jump straight into it. Again, edit this. Oop, type. Let's make a different change here. Let's go M6G, which is a more modern family of instances, and because it's more performant, we're actually going to drop it down a size. Okay, again, we'll open pull request. Upsizing. Okay. All right, so let's switch back here. We can see this is the CloudFormation change that we made just a few moments ago. Already the Infracost bot has run, it's looked at our infrastructure, it's looked at diff, and it's come up and it's told us, hey, Big Red X, this cost has increased by $58,000. There's a threshold set, the default setting that comes with all new orgs, which is $250. So please review this and make sure it meets your expectations. We can see further down here, it tells you which project it was in. Let's pick that up from our code. And if you have some concerns about this, or you like, well, how exactly does this $58,000 get calculated? We can come down here and see, well, it's here. This auto scaling group has increased from $5,000 to $63,000. So that's our $58,000 change. And our instance here has gone from an M8A 2x large to an M8A 24x large. And that's a 75% jump in our overall spend for this particular project. So this is how we're able to do this. You'll also see we've triggered a guardrail, which has had a check failure. So if you're putting like branch protection, sorry, not branch protection, commit protection and approval flows in here as well, you can actually institute guardrails that will block this so that your teams can have to seek approval for it. You can also have a setting there that allows the teams to just dismiss it. So you can have sort of a bit of a soft check to say, okay, you leave a comment and say, at Infracost, dismiss, and it will skip past that approval if your settings allow that to happen. So that's the CloudFormation one. If we go to the CDK example, we made a different change here. And so we'll see that this has actually given us a green check mark for a couple of reasons. We've identified that we had some issues. We had some cost-saving opportunities that had been flagged in the dashboard already, and we've gone and fixed one of them. We've gone and moved to a newer instance in this particular family. You'll also see that the monthly estimate has decreased because we went to a smaller family size as well as jumping up to a lower cost option. And we've told you, roughly how much carbon you're saving from that change as well. So if you've got an ESG or other sort of compliance sustainability targets in place, you can do that. It's a bit of a modest change. And again, if you want the breakdown on how all that works, you can expand these down and it will show you that the CDK stack went from $146 to $56. That's our $90 change. It's as simple as that. All I did was add my repos, make a change, put a pull request, and all the rest happened all by itself. But I'm not done with the demo yet. If we go back to the dashboard, let me show you what we've done in terms of identifying existing issues in the code base. So you saw we've fixed one of these graviton issues already. There's a breakdown of a whole bunch of different cost-saving opportunities in front of us here. So this is a particularly big one, 400. Let's have a look at what that is. Okay, both repos have this issue. Let's take a look at the CDK one. Okay, so it tells us what repo the problem is. It actually even goes down to the resource that's causing this problem. And if we click on this, it'll take us to the issues page, which helps us understand this issue a little more. So we have an RDS instance here that has not been identified as a production instance because we don't have any of our production tags on this. It says, hey, if this is not a production database, there's probably some low-hanging fruit, so low effort, low risk of just dropping this down to being a single AZ. And you're like, oh, that's actually a really good suggestion. Is that what's happening right now? Let's go have a look. And so it will take you to this exact line in your code base where you need to go and make this change. And so here's the definition of this SQL database in our CDK project. And sure enough, multi-AZ is set to true. So if this was indeed an instance that was not in a production environment, a 4-character change. Change that true to false, redeploy. You've just saved yourself $215,000 a year. Now, if we have a look, go back to Issue Explorer. The other thing I wanted to show everyone here is sometimes you have lots of issues. So we've only got the 2 repos, so there's not a great number of, but there's 9 of these. We've got 24 resources that don't have tags on them. We probably want to put tags on. And so what we've seen with the companies we work with is that, if you've got many, many repos, obviously I've only got 2 demo repos attached here, you usually have hundreds, thousands, tens of thousands of issues. And so presenting all that information to your team and saying, hey, go and fix this stuff is almost guaranteed to get no impact at all. And so instead, our approach to helping teams manage that is campaigns. And what we'll do is we'll suggest you pick an issue, you create a campaign around it. You set a date. Like all goals in life, they need to be smart, they need to have a time, etc. And so you set how quickly you want the team to go through this. If you want us to try and automatically create the pull request for you so that all you have to do is review, test, and deploy, you don't have to go and make the changes yourself. And you start it. And what this will do, will intelligently create these issues and put them in front of your engineering team. So instead of going, hey, bang, here's 10,000 things that your teams need to fix, instead, what they'll be presented with is sort of a drip-fed approach that is managed, able to be managed effectively throughout their existing workflows without overwhelming all the other BAU that needs to happen. Because that's what happens in most organizations. They'll either have this tick-tock cycle where maybe once a year you'll dedicate some time and go, all right, we need to go and fix this quickly. And so you'll dedicate a couple of weeks to try and do everything all at once, which is not a very sustainable approach. Instead, what we're trying to do here is making sure that we have a sustainable way of having constant improvement happening throughout your infrastructure, constantly optimizing costs, constantly reducing waste, constantly helping you modernize and embrace FinOps best practices. These are especially useful because, as I said, even with the best guardrails and policies and everything in place, you're always going to end up with issues. We can stop many, many, many of them. Prevention is always the best medicine. But the reality is the world changes. You might have a team that goes out and buys a whole bunch of RIs. And so then all of a sudden there's specific instance families that you want to be gravitating towards because you've got cost benefits if you negotiated on those. Maybe there's re-events just happened and a whole bunch of new instances that have a better price to performance ratio have been announced. And so you want to move up into those. Or the other one that catches a lot of people out these days is extended support. And so if you're using a version of RDS that is, a few versions behind and is no longer considered, long-term stable and should be upgraded, you'll incur a 30% price penalty for continuing to run that instance. And so AWS are trying to get you to move off those instances. And the way they do that is by putting a financial incentive there. But that's catching a lot of companies out. And so we're able to help you understand how broad is that problem, how many instances do you need to upgrade, but also help you manage upgrading those things and modernizing them in a really sustainable way. So let me switch back. That's the demo. I'll switch back. Recap on what we've gone over today. I know that was really short and sweet, but that's because of how quick and easy it is actually to get set up here. Fixing the problems after the fact is definitely the most expensive and disruptive way to solve them. We really want to help companies shift left and be more proactive and preventative in dealing with these issues. Don't think if you're in a bad way, it's not your team's fault. This is just a really, really hard thing to get right. We see so many companies that are struggling with this. They're doing great. It's just impossible. You can't be, the reason is you have to be 100% right 100% of the time. All it takes is that one character missed, you've got a 10x increase in waste. And as I just mentioned then, like perfect prevention is great, but even then, there are still so many reasons why you'll need to go back and modernize things and make things cost efficient and reduce waste. And so running targeted campaigns to achieve these results is the most consistent and sustainable way of doing this that we've seen. And so with that, thank you for your time. I haven't been watching the Q&A or if anything's in there, but hopefully Michelle has. Here's my details. One of our core company values is customer, not customer. We want to go through this journey with the people we work with. So you've got my details here. Feel free to reach out. I will get back to anyone who does. There's the website homepage, and we also have a Slack. So if you do start using it and you want something, jump on there. We've got pretty good round the sun coverage, lots of team. I'm in Australia, lots of engineering in Europe, a lot of the companies in America. So wherever you are, whatever time zone you're in, I'm sure we're going to have you covered. So thank you.